Okay, so again, good evening. Okay. So we'll continue with our discussion last time. Umpisa na tayo ng shear and moment and beams. Tapos hopefully we could end up to the moving loads. And I have also some other topics if we could continue after moving loads. Another slide. So there are three students who were able to submit the assignment last three or assignment. I'll just check it later, but we're going to discuss and answer that problem. So just a recap. So you have here the orientation of the beam when you are going to cut the section. Going here, these are the positive direction. Going here as positive, here also as positive, also for the positive moment. And then the plotting of the shear moment diagram. Okay, so this is your assignment. So we have here, this is a board exam type. The entrance of a warehouse has a roof that supports a roof load of 8 kilonewton meter. It is being supported by this column. So the beam is BC is considered as simply supported. You have an overhang and at 1.5. You have your point A, point B, and point C. Okay, so the question is, first, to determine the vertical reaction. So what would be the vertical reaction at C? Obviously, there's no horizontal reaction. There is no horizontal applied load on the beam. Okay, so you have RC. And then you are going to determine the reaction also in the column support, which is here, RB. Okay. Number two, determine the reaction at the column. So first reaction at C, then reaction at the column at B. Then determine the maximum negative moment. In other words, we just have to draw the shear moment diagram, or we can just cut, but it would be better. We can formulate with an equation to give the maximum negative moment, but it would be better to just draw the shear moment diagram. Okay. So let us compute first. As you can see here, you have here, first we compute the reaction at C. Okay, and then you have here also RB. So we take moment. If we take moment at C, we can compute RB. If we take moment at B, we can compute RC. So we take moment here at C equals to 0. So what is the direction of our forces? It will be clockwise forces is equal to counterclockwise forces. We can have that one or this one. Clockwise moment is equal to counterclockwise moment. So summing up moment at C, you have RB times 6, RB times 6. Where's the 6? This one is the 6. Okay. What else? Actually, we only have two forces. We have here the reaction, the resultant of this load or this uniform load, which is just equal to 8 times the span 6 and 1.5 is 7.5. Okay, this is 7.5. And then we have here the distance. Here we have here the distance, just the 1/2 of 7.5. So this is just 7.5 over 2. Okay. So we can have this RB is in clockwise direction, and this 8 times 7.5 times 7.5 over 2 is in counterclockwise direction. So you can just do in this manner, right? So you have 8 times 7.5 times 7.5 over 2. Over 2. So we can therefore compute RB. If you have calculator, you can try what should be the value. So I think that is, okay. So you have this value is equal to 37.5. Now, if you just have to sum up this RB and RC, okay, RB and RC, we sum up forces vertical equals to 0. You have RB, okay, this one, and then RC is just equal to the total load, which I already introduced to you earlier, 8 times 7.5. Okay, so you have this one. So we can compute therefore RC. Now, how did you come up with this shear diagram? This is shear diagram, and then this one is moment diagram. Okay. So as we discussed last time, the load diagram is just equivalent. Okay, the load diagram is just equivalent, or the area of the load diagram is just equivalent to the shear. So if you're going to compute this one, this is just the area of a rectangle. Okay, so the length is 1.5 and then the height is 8. Okay, so shear here, this 12. So we can say, let's say this, we write here shear B. Okay, this is shear B. Let's say shear B1. Okay, shear B1. Okay, is just equal to this area, 8 times 1.5. Okay, so 8 times 1.5 is just equal to 12. 8 is in kilonewton meter, 1.5 is in meter, so this one is 12 kilonewton. Okay, since we already have calculated that RB is equal to 37.5, this is 37.5. So therefore, if we have this, let's say this is VB2, okay? So VB2 is just equal to 12 is negative, which is it's down. I could write it here, negative 12 plus, okay? The reaction, which is 37.5, okay? So this one will give us 25.5, okay? This is already in kilonewton. Okay. Now, how about this negative 22.5? So that is VC, okay? I write here. This one is VC. So VC is just equal to, you have your VB2, which is 25.5 positive, 25.5, okay? And then you have this area, okay? Okay, okay. We have this one. We have this particular load of this size, 6 meters. So you have your 8 times 6, okay? 8 times 6 is just 48, okay? This is 48. So it's going down, so that means it is negative 48. So obviously, you have negative 48 plus 25.5 is 25.5, 22.5. Am I right? Let's check now. 48 minus 25.5. Okay, it's 22.5 kilonewton. Okay, so this is 22.5 kilonewton. And we have RC is equal to actually 22.5. That's why this will just go back to, for example, go back to here. Okay, so obviously this 22.5 is the reaction at C. This one, this total is the reaction at B. 25.5 plus 12 is just 37.5, which is the reaction at B. Now, taking at computing the moment, this area, if for example, this one, this is moment B. If we have this one as moment B, how are we going to compute moment B? It's just equal to this area. Okay. What is this area? Okay. 1/2 of, this is 1.5. This is just equal to 1/2 of 1.5 times the height, which is of the triangle, which is the shear, is just equal to 12. So it is just equal to 9 kilonewton meter. It's negative because it's going down. Okay, we can just write 9 kilonewton meter, but we all know that it is negative. Okay. Now, how about this maximum pass? This is maximum positive moment. Okay, this is maximum because maximum moment is when the shear is equal to 0. This is 0. Okay, so moment is maximum. With the shear 0, moment is maximum. How are we going to compute the x? So let's consider this area. Right. Okay. Let's consider this area. To compute for x, this is just, if you are going to extend this one, you are going to consider this area to compute for x. So if you have that area, this is x, and this is 8 kilonewton meter. Okay. Okay, so the corresponding value of shear here, okay, the corresponding value of shear is equal to 25.5. Okay, the shear is 25.5. So if you are going to equate that one, the shear is equal to 25.5 is equal to this 8 times x. Okay, so we can compute the value of x. So what's the value of x? 25.5 divided x is just 3.8 and 75 volts. We can have 3.2. Okay, 3.8 and 75. And then how are we going to compute this area? Of course, this is just the area of this triangle. Okay. So what is this area? I'll just write it here. For example, this one is moment M or X for maximum. So you have a moment X or MX is just equal to this area, the triangle, 1/2 times 25.5 okay, times 3.8 and 75. 3.8 and 75. Okay? So mx is just equal to 31.64. Okay? 31.64. Now you can check it. You can check it because this area should also be equal to 31.64 to make it 0. Okay? So 1/2 of 2.8, how do you get this 2.8? Is just equal to 6 minus 3.1875. So you got 2.8125. So this area is just equal to 1/2 of 2.8125 times 22.5. This is negative because it's below this line, considering diagram going up as positive, here is negative. Okay? So I'm sure this will become 0. So the question to compute the negative moment, so negative moment is equal to 9, okay? For question number 3. Okay? Is that clear? Okay. If I am clear, thumbs up. If I have questions, you can raise your question. Okay? Thank you. Now, I want you to, actually, it's already a calculation, but I've already shown to you. I want you to try this activity. Go to your classroom. You have your week 6 activity 1. Just try this one. Click it, then answer it. So you have to compute the maximum shear, maximum positive moment, and maximum negative moment. Try nyo lang, okay? Mga 10 minutes, okay? Whether you finish it or hindi nyo matapos, discuss natin after 10 minutes. Try nyo lang, okay? Madali lang naman to para medyo ma-practice lang.
Sir Jim, nakamute ka, Jim. Sir Jim. Balik natin, Sir Jim, atras.
Okay. Thank you. So as I was saying, we calculate, the question is to compute for maximum shear and then maximum moment, positive and then negative moment. And to do that, first we need to calculate reaction A and then reaction C. In doing so, just have to equate clockwise moment forces to counterclockwise moment forces. Or we can do it also by having the sign convention, clockwise as positive moment. So obviously this is negative in this direction, counterclockwise. So you can write here negative 25. And then you have here, this one, the resultant of this uniform load, you have here 10 times 3 and 1 is 4. Okay, 10 and 1 is 4. Okay, so this is 10 times 4. We take moment here at A, so the distance over here from here is just equal to, okay, this is 4, this is 2. Okay, from here, this is 2, okay, plus 2, you have 4. Okay, then you have here RC in counterclockwise direction, that's why you have negative 5 RC. In other words, we can compute RC is equal to 27 kilonewton. Now, taking moment at C, we can also compute RA, but we can also have this summation of forces, RA plus RC is just equal to the vertical load, which is just 40. Okay, 10 times 4 is 40. So if your RC is 27, it follows that RA is 13. So in other words, this calculation is correct. Okay, we take moment at C. Okay, 5 RA is in this direction here. Okay, negative 25 because it's counterclockwise. Then 10 times 4, the distance over here is just equal to 1. So it's up to you how you're going to calculate. This one will lessen your time, especially for the board exam type. But make sure that prior to this calculation is all correct. Okay, so the question now is to compute the shear. Okay, shear computation is what I have shown you earlier in the early problem. VE, okay, VA is equal to 13. Okay, so it is just like you have here A or VB or VA, okay, or reaction A. You have 13. So take note, in our rule, general rule for plotting shear moment diagram, there is no load here. So that means only reaction that is going up. This one is equal to 13. So it's going up. Going here is 13. Since there is no load to plot, just make it straight. Okay. Then after this one, the moment this 25 doesn't affect, okay, in the shear diagram, it is only important in the moment diagram. After this one, you have this 40. So you have 13, okay, plus negative 40. Obviously, that's going down. Okay, so that's why you have negative 17. And then going up, RC is equal to, what's RC? 27. So if it goes up 27, positive 27, in other words, there is a positive 10 here. This one should be only here. This is just small than this one. Graphically, it's not correct, but the value is correct, okay? And then you have this area, which has 1 meter in distance. 10 times 1 will become 10. Since it's going down, that becomes negative, so that will just close the shear diagram. So you have here the shear diagram, the maximum shear between 13 and 17. Okay, you have 17 is the maximum shear. Depending on the question, sometimes the question there's what is the positive shear maximum, what is the negative shear maximum. So this one, you're only asked to compute for the maximum shear. Okay, let's continue. How about positive and negative moment? Okay, negative first. So you have here, okay, earlier, this is our diagram. To compute for moment D, okay, we have to consider first this area, okay? This is positive. So starting from here, okay, take note, this is 0 degree in the shear. In moment diagram, we expect that it is first degree. So somewhere like this one, something like this one, because this is positive, okay? This area is positive. So here from 0 plus this area, which is obviously this is 13 times 1. So you have here 13, okay? That's positive, okay? Then how about MD prime? Because there is this 25 counterclockwise moment. So from 13, it will goes down here. So there is MD prime. If this is if this one is MD, there is also MD prime here at the bottom. So this is the calculation actually. You have just there's this 13, because this is at the upper portion. Then you have here to less this 25 because it's counterclockwise. Then you got here a negative 12. Okay, this is the negative 12. And then you also have this one, which is just 13 times, again, this is 1, this is 1. Okay, so you have negative 12, just copy. This is for the moment B. Okay. Okay. So you have this area, 13 times 1. So you have negative 12, and then 13 plus 1 will become 1. So this is, just have to connect because this one is 0, 0 degree. In other words, this one is first degree. And then, how about this area? Okay. First, we need to determine what is this value. Okay. X. This one is 13. So we can just have to consider, if I'm going to extend this line here, I will just consider this area. So if I'm going to calculate it here, it is just like you have this load. Okay. You have here the beam. You have here 10. You have X. Okay. The corresponding value of shear is equal to 13. Is just equal to 10 times X. Obviously, you got X is equal to 13 divided 10, 1.3. So this one is 1.3. Okay. If this one is 1.3, in other words, this could easily be determined. This becomes 1.7. Out of this one, we can calculate this area. Area of the triangle. Okay, this one. You have here 1 positive. For MF, if this is F, okay? If this is F, point F, we need to compute the moment here. Okay, so you have 1/2 of 13 times 1.3. This is the triangle, okay? Ayan. Ito yan, oh. Okay, ito yan. 13 and then 1.3. So you have 9.45 positive. Oh, hindi nalagay ko dito. Okay. 9.45, ganun. Okay? Since this one's first degree, kaya ito, second degree. Curve na siya. Okay? Okay, now you have 9.45. You are going to subtract this area. What is that area? It's just simply 1/2 of 17. Ano yung 17? Ayan, no? 17. And then 1.7. Ito. So you have negative 5. Ito, i-connect ko lang to dito. Okay? Ay, oh, sorry. Okay, ganon. Okay? So ito yung kadugtong na area na hindi ko na nagawa ng curve. Okay? So if this is negative 5, we can just add this particular rectangular area, which is just 10 by 1. Kaya ito yan, no? 1. Okay? Asan na yan? 5. Ano no? Ito yan. What I mean is this area. Okay, something wrong with here. To ganito dito, dapat ito. Okay? Kasi first, mali ito. Ano? Ganyan. Because this one is first degree. Okay? Mali ito. Dapat ganun lang. Okay? Sorry. So this is triangle. 1/2 of 10. 10 yung height. Okay, balik ganun yan. Ano? 10 yung height. And then 1 meter yung base. Okay, so you have 0. Kasi dapat mag-meet talaga siya dito. 0. Okay? Free end. Okay? At the end of the beam, the moment is always 0. Here is 0. Okay. So, what is the maximum negative moment? Okay, ito na 9.45 dapat dito. Okay? 9 positive, I should say, positive moment. This one should be positive, okay? This is positive moment. Ito kinumpute natin 9.45 kilonewton meter. Okay? And the negative moment, andito naman malinaw sa baba. Okay?
Sir,
Okay, Sean.
paano po yung 13 kilonewton meter?
Ano? Wait.
Sa ano po, yung maximum positive. Yung 13 kilonewton meter.
Ito.
Opo.
Ito. Ito palang maximum na positive moment.
Opo.
Ano bang question ng Kwan? Sorry. Tama. Good observation. Ano ba yung question doon?
Maximum positive moment.
May kumba na between... Ayun, maximum positive moment. Hindi ko nakita. 13 pala. Okay. Kasi 13 times 1 lang. Mas mataas pala yung mas malik. This is positive. Ito yung sagot. Okay?
Okay po.
Very good. Hindi ko nakita. Yung pala. Yun ang sagot. Okay? 13. Hindi 9.45. Okay? And then, edit ko na lang yung sa Google. Hindi ko nakita ito na tinignan ko nung nagkuhan ako. Ito pala, 13. Huh? Very good. Negative moment is, ayan, 12. 13 positive. Negative is 12. Okay. Some more questions? Okay, let's proceed. Bago kayo mag-dinner break, let's just continue. So, discuss lang natin quickly the flexural stress. Ito, this is very general, applicable to sa mga succeeding din ng mga subjects sa steel structures, theory of structures. Okay? So, this is the general formula. The bending stress or flexural stress is equal to moment, C, is the centroidal distance and the moment of inertia. Kung may rectangle tayo, okay, ito yung C natin. Actually, minsan may C tayo na kinukompute dito, depende sa tanong, ano? But since if we are going to compute the maximum stress, that should be the maximum distance from the centroid. And that is at the topmost, okay? Pagka rectangular. Pero sa mga irregular in shape, halimbawa, mayroon kang ganun T1. So obviously, andito yung centroid, neutral axis. Kung magko-compute ka ng maximum, it has to be, baka ito yung maximum. Okay? Wait for a while, ako ko lang yung charger. Baka malaubat ako. Just like me. Okay. Let's continue. So para makompute yung maximum moment, na sinasabi ko lagi, okay, dapat yung C maximum. Kung may mga ganitong, okay, ito mas mataas, so ito yung gagamitin mong C. Because in the design, you always look after the maximum value, maximum moment, for you to get the maximum stress. Okay, so just what I was saying, if this is D, this C is equal to d over 2. Okay? Ito yan. D over 2. And then I, BD cube over 12 for a rectangle. Okay? So substituting further, then we can have this general form, this formula specifically for a rectangular section. Okay? So we also have values for section modulus for us for review. S is just equal to I over C. Okay? I, moment of inertia, and then C, the centroid. Okay, distance from the topmost for maximum value. In other words, S for a rectangular section, you have this one. And then we can also have this relationship, as we have before, that we can also use this one. Kaya nga sa design ng steel section, yung mga steel properties nakalagay doon. Moment of inertia, meron with respect to X, with respect to Y. Then you also have S with respect to X, with respect to Y. So pag nagse-select tayo ng section, pag may moment tayo, ito na ginagamit natin minsan. Kasi kung may moment ka, may stress, then we can compute the required S. Your required S. Sineselect lang natin sa table of structural steel. Okay, so this relationship is also important. Mas mapadali. Kasi kung sa I ka pa, dito pa, medyo tatagal ka pa ng calculation. Okay, so let's have this example. Cantilever beam, 60 millimeter wide by 200 millimeter high. In the height. So, mga dito, 60. Dito naman is 200. You have 6 meter long. Carries a load that varies uniformly from 0 at the free end and 1,000 Newton meter at the wall. So, basically, sa gitna, mga 500 na lang to. Okay? Here, mismo dito, 500 yan. Okay, sa problem, kailangan natin. Compute the magnitude and location of the maximum flexural stress. So first, if you're going to compute the magnitude and location of the maximum flexural stress, so we get the maximum moment. And the maximum moment, obviously, is occurring from this, here from this support. Okay, so from the formula itself, ito lang kailangan natin, na formula. From this formula, we need M. So ito lang, take moment here. Okay, take moment at, let us say this is A. What is the value of moment here? Okay, it is just equal to, what is this this resultant force of this load? Resultant load, I should say. Ito lang na triangle, this triangle is just equal to 1/2, kay triangle man siya, 1,000 times 6. Okay, pero ang kuha nito, ang location is not here in the middle. Dapat nandito siya. Kasi nga triangle eh. Okay? Erase ko to. Okay. And the location of that one, for we know that the location, the center of the triangle is at 1/3. Okay? 1/3 from here. So this is 1/3 of 6 or 6 over 3, which is equal to 2. Okay? This is the centroid. This is the area or the load. Ito, 1/1006. So ito yung magiging moment. Pag sinubstitute natin, 6M. This is 6,000 Newton meter. Naglagay pa ako ng 1,000. Kasi nga 1 meter is equal to 1,000 millimeter. Pag nag-compute tayo ng mga stress, dapat Newton millimeter na tayo. Kasi pagka Newton millimeter lahat, our answer will be in megapascal. Okay? Megapascal is just equal to Newton millimeter squared. Okay? Tandaan nyo lang to para hindi na kayo nag-conversion. Kasi pag may kilonewton ka dito, tapos meter lahat, so maging kilopascal yan. Mag-convert ka pa ng 1 megapascal is equal to 1,000 kilopascal. Okay? So next, determine the type and magnitude of the stress at a fiber 40 mm from the top of the beam. So kung halimbawa may beam ganito, ang sabi niya, kung itong neutral axis, ang tinatanong niya is, in a stress in a fiber 40 mm from top of the beam. So if the height is 200, pinapa-compute niya na stress is dito lang, yung value niya na 40 from the top. If this is 200, it follows that this one is 100, okay? Which means this one is 60. Okay? 60 ngayon yung magiging C. Okay? Pero again, pinapa-compute din yung magiging moment at a section 3 meter from 3 end. If this is 3 meters, ito lang yung pinapa-compute niya. Ibig sabihin, what is the moment here? Okay? 500 to, okay? Ulit. Okay? Anong moment niyan? So, yung moment niyan, if we're going to cut this section, erase natin to. Ito lang yung consider natin. Okay? Andito ngayon yung magiging resultant. Okay? Andito siya. R. Which is just the area of this triangle 3 meters from the free end, which is equal to 1/2. 3 yung base. Height is, of course, kung 1,000 yan, nasa gitna, 500 ito. Okay? We'll just take moment from this mid-span or 3 meter. So, okay, what is this distance? The center of the triangle is just 1/3 of the base or height. So 1/3 of 3, which means this is equal to 1. Okay? So, may moment ka na 1/2, okay, area ito, no? Area. Or this R times 1. Okay? Ito yung R. Pag minultiply mo ng 1 na distance, magiging moment. Okay? So we have this moment. IBD cube over 12, compute natin. Substitute C, 60 lang. Okay? Ito yung sinasabi ko na 60 lang kasi yung pinapa-compute is 40 mm from the topmost fiber. Mula sa taas. Mula dito. So ito yung magiging value ng stress at this value. In other words, kada distance from C, may particular siya stress. Dito sa topmost, yun yung pinaka-maximum. Yun ang ginagamit natin sa design. Okay? Pero ito yung specific question for whatever reason and purpose. Okay? Ito yung pag-calculate. So we have 1.125 megapascal for this particular stress at 3 meters, distance from the free end, at saka dito lang. Okay? Dito lang na fiber, hindi sa taas. Hindi dito. Okay? Is that clear? We can move. Thumbs up, please. If everything is fine with you. Okay, so we can move to our next problem. Thank you. So how about this one? You have here, determine the minimum width B. So parang design siya, no? Ito ang itong design. May mga load. Tayo nag-compute niyan. Now, we are going to compute the width B, or if we have this beam. Ano yung B daw? Okay? And the flexural stress is not to exceed 10 megapascal. So, ang allowable FB is equal to 10 megapascal. Okay? Dapat hindi na doon tumaas. Depth, 200. Pang-finifix na sa 200. Depende siguro sa design, architectural design, hindi na dapat lumaki doon. Sa B ka na lang mag-adjust. Okay. So, first we calculate R1. Reaction. Ano? Para makompute mo ang B, yung width, dapat mag-compute ka muna ng moment, maximum moment. And from there, you can get the reaction, the B. So what is R1? Okay, let us take moment here. Let us say this is 0.1, this is 0.2. We take moment at 2 equals to 0. Okay? Ito muna. Okay? Clockwise equals to counterclockwise. So, ano yung mga clockwise forces dito? Okay, R1. R1 punta dito. Okay? So you have R1 times that distance 3. Okay? What else? Itong 2,000, nasa gitna, ang ano niya, resultant load, which is just 2,000 times, yung distance, total yung distance niya is 4. Okay? So 2,000 times 4 is just equal to 8,000. Okay? Pag nagpaikot tayo sa 2, this distance is just equal to 2. Okay? So in other words, you have here, ito counterclockwise na kasi itong R1 lang ang clockwise. So equate na lang natin para wadi na tayo mag-transpose. Okay, this is 8,000 Newton. Okay? So you have here 8,000 multiplied by 2, yung distance. Okay? What else? Ito, may 5,000 ka, may distance naman na 1, malinaw. Counterclockwise din. Okay, so you have 5,000 times 1. Pakalculate nga, bigyan niyo sa akin yung value ng R1. Hindi ko na-calculate eh. Pakalculate, then 16. 7,000 ba? 7,000.
Yes, sir. 7,000.
Okay, thank you. So sabi ko kanina, pag kung medyo confident na tayo sa tamang sagot, ito na lang gagawin natin. R1 plus R2 or 7,000 plus R2. Ano? Para mas madali na. Is equal to anong total load? Ito naman, no? 8,000 plus 5,000. Okay? So we can compute na R2. 7,000. 8,000 minus 7,000 is 1,000. Okay? Plus 5,000 is 6,000. Tama ba? Dapat 13,000 yung total. Tama na siguro. Okay. And now, para ma-compute natin yung moment, mag-shear moment diagram na lang tayo. Okay? R1 is 7,000. Ito is 7,000. Ito is 6,000. Okay? So, plinat ko na para mas madali. Ito, area, going down, ano? This is 2,000 times 1, negative 2,000. Pataas, may 7,000 na pataas. So, ang remaining dito 5,000. For us to check, ito, add natin regardless of the sign, 5,000 and 2,000 is 7,000. Equal dito, ano? Para pag-check. Kasi itong 5,000 and 2,000 is the reaction. Okay? Now, if you have here, itong area naman, ito naman, 2,000 yan. Times 2 is 4,000. So kung 5,000 ito, may pababa dito na 4,000, so may matitira pa rin. There's still positive 1,000. Okay, we're talking about Newton, okay? Newton. May pababa dito na 5,000, so matitira dito is negative 4,000. Okay? And then, meron din ito na remaining dito. This is again 2,000 times 1 is 1,000, 2,000 pababa. So 4,000, dadagdagan lang ng negative 2,000 ulit, maging negative 6,000. Which is just equal because R2 is going up 6,000, babalik siya dito. Okay? So tamang diagram na to. Now, this area is just the value of the moment. Alam naman natin itong triangle, the area of this 1/2 of 2,001 is just negative 1,000. Ano? Ito na yan. Ito, area nito is just trapezoid, okay? The area of that one, which is 5,000, is just equal, sabihin natin, moment. Okay? It's just equal to 5,000 plus ito pa rin, 1,000. Average nyo lang, divide 2. Okay? Multiply ng length. Okay? Length is 2. Okay? Obviously, we cancel this 2. Okay? Tama ba? 5,000 ito. This one. Mali. Again. Okay. Kasi may 1,000 pa dito. Okay? Kasi may negative dito. So this one is 6,000. So this moment, let us say this is X. So moment X. This one, Area pa lang to, okay? Area nito. Okay? So moment x is just equal to, first may moment dito na negative 1,000. Okay? Plus positive area. Ito positive area na 6,000. Okay? So 6,000, you have here 5,000. Okay? Ito na yan. Non-Newton meter. Okay, this area should be equal to 5,000. 5,000. As I have said earlier, area ng trapezoid, yung area ng trapezoid is just the average height multiplied by this width. Ang width is 1 meter. Average height ng 4,000 and 6,000 is 5,000. 5,000 times 1, that becomes negative 5,000 kasi pababa siya. Evident naman dito ang negative. Okay? So mag-meet dito ng 0. Since this one is first degree line, first degree, so magiging curve na dito. Okay? Magiging 2 degree dito. So we're just after actually the maximum moment. Okay? Ang maximum moment, makita natin 5,000. Okay? Wala na pala dito yung. So maximum moment na 5,000. So we have here FB. FB is equal to 6 MBD squared. Let's substitute. Sabi sa problem, maximum na FB is equal to 10. So you have here 10. Okay. This is Newton millimeter. Okay. You have here 6. Ano yung moment? 5,000 Newton meter. 1 meter is 1,000 millimeter. Magiging 5 times 10 to the power of 6 para Newton millimeter. Okay? Ito, Newton millimeter na to kasi megapascal. Okay? Newton millimeter squared. Hindi ko na kailangan sulat. Ang tinatanong is B. Anong B? D. Ano yung D? 200. 200 millimeter squared. Okay? So, ang millimeter squared dito magka-cancel out. Newton, ito, magka-cancel out. Ito, okay? Ito, magka-cancel out. So, ang remaining na value is B, which is millimeter. Okay? Paki-calculate nga. Try natin. 6 times 5 is 6.
75, sir.
75, ano? Check nyo na lang, okay? So that is 75 millimeter. So in this problem, this just shows how you can compute maximum shear, maximum moment, and at the same time, if you have some question related to calculation of B, calculation of D,
Tama ba, sir?
check ko. Hindi ko na-
75 millimeter? Ang liit naman, 200 millimeter.
Kay kahoy naman siguro to.
Okay, okay.
I'll see, I'll check. Kasi maliit lang din naman ng 1. Check ko, ha? May mga kahoy, di ba? Mga 3x8. Mga sa atin, 2x6, 2x8. Di ba? 6 times 5 is 20. Check ko nga yan. 6 divided 200 squared. Okay. So, you want to take a break first for 10 minutes? Baka mag-snack muna kayo? Dinner? Okay, okay. 10 minutes muna tayo, okay? Break tayo saglit. 10 minutes lang, okay? Dinner muna tayo saglit.